And today is all about solving a two-step equation. So back on Friday, we saw something very similar. We had multiple steps, things that hopefully we can kind of refresh ourselves with in order to get variables by themselves and solve equations. But now we're just going to add a layer on top of it, because on Friday, what we discussed was solving equations that had a negative sign in front of it. Remember, we kind of added or subtracted, moved some things over to get rid of those terms, try to get our variable by itself. And then we just had to take that number that we got after simplifying and divide by -1. Well, in these examples today, we might not always have a negative sign in front of our variable. As you see here, there's a 2 in front. Sometimes it might not even be a whole number. It might be a fraction, and that's going to help us determine, what steps do I need to take in order to solve that type of equation. But we're going to go through, a couple different examples here. The first one I'll do entirely on my own, so we have a good grasp of what we need to do for each problem. We'll develop a list of steps and then kind of just see a couple more examples to get us ready to go for the ALEKS assignment later. Sound good? Any questions before we get started? Okay. So in this first example, I have 2x minus 7 equals -3. All right. Now, my objective, and something that we talked about back on Friday, is to get that variable entirely by itself. So I don't want anything in front of it, any multiplication or division. I don't want anything being added or subtracted from it. And what I'm going to do in order to make sure it's entirely alone is to first start by adding 7 to both sides, right? That's an extra term that's over there. We talked about the addition property of equality, where whatever I do on one side, I have to do on the other. So I'm going to take that 7 and add it to both sides, okay? And when I do, and my reason for doing that is because this -7 and the +7 are going to cancel out, right? I'm trying to get rid of that term on one side. So -7, +7 will cancel. And I'm left with just 2x equals -3 plus 7. Well, -3 plus 7, remember that we had some rules for this, some integer rules. It's the same thing as 7 minus 3, right? I'm adding or subtracting those two things and then taking the sign of the higher number. So 7 minus 3 is going to give me +4. Right? A lot of times I use that analogy with like, how much money do you owe me, right? If you owed me -$3 and you gave me 7, you gave me 4 extra, right? So I have 2x is equal to 4. Any questions up until this point? So the first step, get rid of any addition and subtraction. There's still that number that's out in front of my x, right? I need to get x by itself. I want that to be just a variable equals a number. Well, in order to get rid of this, I need to do what's called inverse operations. So just like over here, if I have -7, I added to both sides. Well, over here, I have 2 times x. I want to do the opposite of multiplication, which is what? Division. So in order to get x by itself, I'm going to divide both sides by that 2. Because what do I know 2 divided by 2 is? Or what's any number divided by itself? What is it? Not 0. 1. Any number divided by itself is just 1. So it's going to be 1x, or just x, is equal to, what's 4 divided by 2? 2. Okay. And now I have a variable entirely alone equals a number, and that would be my final answer. So x equals 2 is my answer when I solve this equation. Now, if I were to take that in order to check, I can plug that back into the original equation, right? And see if I get the same thing on both sides. So I have 2 times 2 minus 7 equals -3. I'm sorry, minus 7, I should say 7. Equals -3. Well, what's 2 times 2? 4. 4 minus 7, what does that give me? What's 4 minus 7? Not 2. -3. And I have -3 on both sides, which is what I want, right? That means that when I plug in 2, I get the right solution. So x equals 2. Okay. Are there any questions about that first example? Now these asterisks or these stars off to the side are going to be our steps for this. So what was the first thing I did? So if you look back to this equation here off to the left, what was the first thing I did on both sides? Added the 7, right? So my first step is to get rid of any addition or subtraction. I'm just going to write plus / minus. So any addition or subtraction. And I'm going to do that on both sides. So if I have a -7, I'm going to add to both sides. If I had a +7, I would subtract on both sides. So get rid of any addition or subtraction. Okay. That's always going to be your first step. After I did that, I got down to 2x is equal to 4. Well, what did I do on both sides from this step? How did I get the 2 to the other side? What's that? Not just, did you say distribute? No, not distribute, divided, right? So after I get rid of addition and subtraction, I still have a number being multiplied by x. Well, I'm going to get rid of any multiplication or division. So I'm going to multiply both sides by a number or divide both sides by a number. Okay. And one of the last questions I asked you was, what's 4 divided by 2? That step is just to simplify and check your answer. So your last step would be to simplify. Well, you're not going to leave it as 4 over 2, right? You just want to simplify that to just 2. And then check your answer by taking that 2, plugging it back in, seeing if you get the same thing on both sides. Okay. Any questions about example 1 or any of the steps that we just came up with? Okay. Let's take a look at, we're going to do 2 more examples. All right. We're going to use these steps here to help us solve each of these equations though. So in this next example, all right, I have -3x plus 8 equals -4. All right. If my first step, as we wrote down, is to get rid of any addition or subtraction, what should I do on both sides to start solving this equation? Subtract the 8, right? That's an extra term that's on this side. So I want to move that to the other. I'm going to subtract 8 on both sides. Okay. Well, on the left-hand side, what's going to happen with the +8 minus the 8? They're going to cancel each other out, right? And what's going to be left over? -3x. Good. On the right-hand side, I have -4 minus 8. Well, what's -4 minus 8? Remember, if they have the same sign, I just add them, right? So, and essentially, what's 4 plus 8? 12. But they're both negative, so it's going to be -12, right? Remember, that was one of the integer tricks that Miss Smith brought up the one day. So I've gotten rid of any addition and subtraction, right? My second step is to get rid of any multiplication division. So what should I do on both sides in order to get rid of multiplication or division? Divide by just -3, right? Because I'm trying to keep x by itself. Well, -3 divided by -3, what's any number divided by itself? We talked about that. Just 1, and I'm left with x. On the right-hand side, what's -12 divided by -3? First off, what's a negative divided by a negative? Positive. And then what's 12 divided by 3? 4. Good. So I have x is equal to 4. And then that's your answer. So again, I get rid of addition and subtraction, just move something to the other side. I get rid of multiplication, division, divide or multiply on the other side. I get this value here for my final answer. If you were to plug this back in, 4 times -3 is -12. -12 plus 8 is -4. So you have -4 on both sides. That's how you know you got the right answer. Okay. Any questions about that example? Okay, there's one more example that I want to do. So I have 1/5 x minus 4 equals -1. All right. What do we notice that's a little bit different about this example compared to the first two that we did, or even just the one that's next to it? There's a fraction, right? Sometimes they'll write it as 1/5 x. Sometimes they might write it as x over 5. It's the same thing. Okay, so if I don't want us to get to the ALEKS assignment and get tripped up based off of how they rewrite certain things. Okay. So 1/5 x is the same thing as x over 5. The steps that we take are the same, right? I want to get rid of any addition, subtraction, and then multiplication and division. So with that being said, what's the first thing that I should do to solve this equation? I want to get rid of addition and subtraction first. Let's maybe hear from somebody we haven't heard from. Yes. Add 4 to both sides, right? So I'm subtracting 4 here. I want to add 4 to both sides. Okay. What's going to happen with the -4 and +4? They'll cancel. And what's left over on the left-hand side? So what else? What other term is over here on the left-hand side? What's that? 1/5 x. Right, so this is the -1. Oh, -1 plus 4. Now, careful. So -1 plus 4, you're going from, what's that? +3, right? So again, if they have different signs, you can subtract them and then take the sign of the higher one. So 4 minus 1 is 3. The higher number is positive, so it's going to be +3. All right, so be really careful, and Ms. Smith put it up there again, of the integer rules that you can use to help you simplify. All right. Any questions so far? So now it's a little bit different about this example. Before, we would get rid of any multiplication division, right? We would just divide on both sides. Well, now what I want to do on both sides, if I see a fraction, a way for you to get rid of a fraction is to multiply by the reciprocal. Remember the word reciprocal? So if I said, like, what's the reciprocal of 1/5, what would you say? Reciprocal means you take the fraction and flip it. So instead of 1/5, it would be what? 5/1. What's the reciprocal of like 2/3? 3/2, right? You're just flipping that fraction. So if you multiply both sides by that reciprocal, what ends up happening is this number here and the fraction will cancel out, and you're left with x is equal to 3 times 5. So whatever you do on one side, you have to do on the other. So if I multiply by 5 here, I multiply by 5 over here. What's 3 times 5? 15. And my answer is x is equal to 15. Okay. So the only difference there, if you have a fraction, multiply by its reciprocal, and that will cancel out the x, leave it by itself, and you're just multiplying 2 numbers together on the other side. Okay. Any questions about that example? Anything that we covered today? Everybody good? Okay.